Well, hello, hello, hello. Welcome back. And busy with the next part. And if you feel that you've seen this before, well, you might have, because about a week ago I did a live stream, and unfortunately, um, the stream started jumping, and then I started losing connections, and all of a sudden, halfway through the stream started froze up, and I couldn't get it back. And I just thought to myself, you know what? It's it's time just to call it quits and then start again. So here we go again, part 11. Maybe I won't ramble that much this time. So if you're back here and you going to be watching the stream, let me just explain to you that we're going to do two things mainly tonight. First thing is we're going to have a look at some of the brush over of what we did with the AC, then go a little bit into the DC, but the main part of the focus is I need to get back to redeploying the firmware, because RatRig have released the actual support for the Octopus Max EZ board, and I know that I did it in part 7 in a custom way, and I said that trust me, and that would probably work very well. Well, probably it will work very well. But I'd like to get back to actually trying to using officially what most people would experience out of the box. So I decided I'll just redo it, and we'll just put one more episode in. It shouldn't take that long tonight. I'll show how I did it, and there's one or two little catches that I've also noticed in this interim period that, and I'll explain that. But without further ado, let's get going. What I'm going to do first is I've got an echo somewhere in this room, and I just want to have a quick look if that might help. I forgot I logged into the stream on my other computer. I keep hearing myself. It's terrible in the background. So yes, let's see if that works a little bit. At least now I don't hear myself talking all the time. Okay, so let's get straight to it. Where are we? Let's take maybe like that. So previous stream, we basically made sure we put the AC components in. We wired up AC to the power supplies. We brought the AC along, and we brought it to a bit of a breakout box. And thank you. Coffee's set. Good to have some coffee while I'm doing the stream. And also, what I also have, I've got AC running from the main power. Remember, I've got AC going to this power supply and to this power supply. This being for the Raspberry Pi, and this being for the rest of the board. So I've also got AC running all the way directly into over here. The only difference is on the side, I've got two switches, one that will control that power supply, and one that will control this power supply. Okay, and all the earths between everything is all linked up in the middle. Okay, so that's the first thing. The next thing what we were going to do afterwards was the DC side, and that's where I would like to show what we've done. So instead of me sitting there crimping wires the whole time and showing you how I can potentially crimp wires, it was just easier for me to do the wiring itself. So if we get into maybe, let me just have a think which one. Let's do that for now. Yeah, that'll work. From the negative and positive would be 24 volts that are coming out of the power supply. I took power up to the Octopus EZ. Now I'm going to quickly bring this up and just bring it in slightly so you can see. On the Octopus, board, I'm going to try and hold still. You'll have motor power, and bed power, right? On this board, you can give different voltage. Let's say you're running higher voltage motors. You can run maybe up to, I think, up to 58 volts or close to 60 volts, somewhere like. I'm talking under correction, but in any case, you can run higher voltage motors. Yeah, I think maybe it's 48 volt. I need to double check. I've never run the higher power motors. Then your normal power is what goes to the board to power the board, and then the next one is your bed power. So if you're running a different bed power to the power that you're running in, you can potentially change that voltage slightly up and down, right? Now, in my case, I'm running 24 volts to the motors, to the board, and to the bed, all the same, right, for me. But what I've seen on the RatRig documentation, and we'll get to the RatRig documentation, is they take each one of these and connect it with a separate wire over here. Now, to me, logically, you could probably bridge it. But if I decide later on I want to move up to 48 volt motors or higher voltage motors, or on a change bed, then I would have to cut my bridges and redo them. So I decided I would, in one go, just put all the wiring in and go one set of wires for bed power, one set of wires for the power, and one set of power wires for the motor power. So very simple, nothing to it, just straightforward connections, right? Obviously you can see everything. I'm using lugs on everything. They're actually not fork lugs, they're whole lugs, so they can't even slide out. I just wanted to go a little bit extra with that. And then the last thing you'll probably notice down the bottom here, I've got a double up on 2 wires over here. And that's because I took that power and I went all the way up, right? And I have a 24 volt breakout box that breakout panel that I have there, built up with Wagos, because I'm going to be supplying voltage to different devices. So in the future, I will also be putting in maybe multiple print heads, and each print head would need its own to get 24 volts. So it's already there. All I need to do now is just tap off 24 volts on each one of these. Okay, so that's the 24 volts. You can already see there's a wire going out here, and that goes to this little tool board, which needs 24 volts to be powered. And this is typically what all the print heads will have on them, will be this tool board. Okay, so that's the one thing that I did. Okay, so now let's go back to maybe the other side of this, and yeah, let's go here. So on this side, I've got the power supply for the Raspberry Pi. As we can see, the AC voltage is coming in, and I have taken a USB-C cable and I've run it through, and I've cut it and I've pumped it into there. Now, I know you can take normal wires and you can put your power onto the GPI opens, right? And yes, that is also an option, but I might be running additional cable off this GPI opens for something else that I have in mind later on. So I don't really want to utilize my GPI opens right now. And okay, when I said GPI, it's the input output, but on this connector bus there is 5 volts and 5 volts lines and ground lines where I could have put power directly into. In actual fact, if you look at this, the bottom pin that I've got my finger on, let me get something that I can point with a little better, maybe I can show you. Let's see how to do this. So this pin in 1 and 3 are positive voltage, and 6 and 7, we'll see that now, are also on ground voltages. Now I'll show you that in a moment, but before I get there, we could probably have a debate now as to whether putting power like that through the USB or through the GPIO is the better one. I haven't found any good hard facts and tell me which one's better. So I'm just going with what I feel works for me, right? But there is something I'd like to show while we're at this point, and it's something that I've seen on one or two builds, and where sometimes people have been caught out, and even I've been caught slightly with this, and that's with regards to the voltage of this power supply itself. So let me put that camera down for a moment, okay, and I am going to switch just back to my main view while I position some other cameras. Now, what I'm going to do is I'm going to put a multimeter in place because I want to show you some voltages. And let me see if I can just get that hanging over there. And then we're going to put this over here. So for me to make sure that you can see that, I'm going to switch on my multi-view on that side and remove my coffee out of the picture. Good. And you're going to be able to do that. And then if I go to new view, I decided, let me zoom this one in as well. Where? Created a view just so that we could do this for tonight. So what are you seeing? First of all, here we've got my 5-volt that I'm going to supply the Raspberry Pi with. Okay. And why won't you focus? Is that better? And then we've got the Raspberry Pi with the pins over here, right? Now, I've got this connector. Let me put it in front there. You can see, which is basically already pre-configured for the GPIO pins. Right? So if I go and show you the pin outs on that bus or on that connector on the Raspberry Pi, let me just go here. Right, you will see that pin 2 and pin 4 are your 5 volts, and pin 6 and pin 9 are your grounds. Now this connector that I have, which I'm not going to be able to get into focus too easily over there, I'll just hold it like that for a second, you can see, is already pre-configured in that way, and it's got 2 wires. A red wire that's basically joined together, right, goes to the red and right, because this was built to actually power a Raspberry Pi from an external power source. Okay, and when I connect that to the Raspberry Pi down the bottom, I am able to obviously power the Raspberry Pi of that, but I also want to be able to measure the voltages of the Raspberry Pi itself. Now, before we actually measure the voltages at the Raspberry Pi, I want to show you that I'm going to connect my there, like that one there, the negative, positive, if it will stay. See, hello Evelyn, Mighty Thunder, thank you for joining again. Okay, so I'm now going to switch on my Raspberry Pi power supply, and you will see there's my voltage, 5.05 volts. Now, one thing that we must know, and a Raspberry Pi 4, a Raspberry Pi 3 was quite comfortable with a voltage, right, I think up into 4.989, 4.9 somewhere, right? And it didn't have any issues. But a Raspberry Pi 4 has a bit of a problem in the sense that it doesn't like voltages under 5.1 really. and it works, but every now and again you get under power voltage alerts. So the best thing for us to do is to actually check the voltage on the Raspberry Pi and make sure that we're actually giving the Raspberry Pi enough voltage. And in wanting to do that, the first thing I want to do is I actually want to show you the difference between measuring the voltage at the power supply and measuring the voltage at the Raspberry Pi. So on the power supply, you will now see 5.50 volts, right? Which is already slightly under. Now, if you buy a Raspberry Pi charger, the specifically one for the Raspberry Pi 4, you will notice that the voltage is about 5.12, give or take, 5.12, somewhere over there. And by buying your own power supply, you've got to be careful that you're not under voltage. But now let's go to the Raspberry Pi itself, right? So I'm going to disconnect there. Disconnect from that one. And I'm now going to connect to the actual Raspberry Pi. You saw it was 5.06. And you can see in the camera here, I'm just connecting up to these wires. And there you go. Our voltage is 4.99, which is a bit of a problem. Shouldn't be that low. We have a risk that there could be a low voltage warning on the Raspberry Pi. So we're going to adjust this. Given that there will also be a bit of voltage loss over here, but your voltage loss comes through your cable and on the Pi itself, on the circuitry inside the board, there's a bit of a power loss. So we're really just trying to compensate a little bit for that power loss. Now, I want to have my voltage at 5.1 minimum. For the safe sakes, I'm going to go up to 5.15. As far as I know, you can go up to 5.25 as the maximum voltage on the Raspberry Pi before it starts shutting down on its own. I think it's got a bit of a protection building. So I need to go to this little screw over here. And I'm just going to slightly turn the voltage. Just small increments, very small increments as you go along. And I'm going to get this voltage up to about 5.15. 5.1 being the comfortable voltage. I just want just that slight bit more, just in case. That 0.005 is going to do nothing to it. It's just going to, if there is a bit of a power request and the power supply doesn't supply enough, or there's a dip, then we can cater for that. 5.16 is fine. Okay. So there we have it. Now my Raspberry Pi has got at least a decent voltage, and I think that's something that should be documented for people building up their printers that are going to push their printer a little bit harder. That, hey, you know what, extra bit of voltage on the Raspberry Pi at about 5.15 is a good idea. Okay, that being said and done, that's all I'm going to do from a wiring and a power perspective. What I will tell you is on the 24 volt power supply, I'm actually going to set that voltage at 24.2 as well, give or take. So about 24.2, and make sure that my power is sufficiently above 24 volts, but not too far. Happy to have some people comment at a later stage when you do watch this video. It'd be interesting to have other thoughts on that, but yes, for me, that's what I'm doing now. Right, let's move this camera out of the way. Let's move our multimeter out of the way, and we can get to an actual firmware. So let's go to the website and we go to the RatRig docs and we go to the firmware, and we on the left hand side I want to show you, yeah, if you go to installation or introduction, where is it? Oh, yeah, this is what I want to show you quickly. So the supported boards, I just want to show you that if you ever go into this section, you'll see all the supported boards that are supported by RatOS with pre-made configs. You can see my Max EZ board was not there previously, it is now, and if you go inside there, they've got the diagrams as to how the configuration is built in terms of what is being connected to where. So you can see that the left motor, the rear motor, and the right motor are connected to these three. When I did my manual configuration a little while ago, actually connected it with that one, but for this, because the RatOS have done it this way, I've now moved my drivers up to here, and I will follow their configuration as is. Again, you can see they've taken from the power supply individual wires, a black and a red to each one of these terminals. We've done the same, right? Just keeping in standard with what they're doing. And yeah, I think then they also talk about the fans. If you're going to have part cooling fans, 2-pin fans, you're going to use these pins, and if you're going to have 4-pin fans, you're going to use these connectors. So there's quite a bit of new information on the website. Please have a look at that. Make sure that you look at the website before you do your firmware. Going back to the installation, again, we would go to the GitHub and we would download this one, right? Because I'm using a Raspberry Pi 4 with more RAM. If I was using an older Raspberry Pi with less than 1 gig of RAM, I would then use the 32-bit image, which would be better in terms of memory usage. Okay. Coming back to this page, we would then use this Boolean etcher, and we would etch it. Now, I'm not going to write the file to the SD card. We've done this before. Please go look at part 7. I made lots of mistakes there, but there's a lot of good information there as well on how to do it. And then I also, in part 8, between part 7 and part 8, worked out how to use the RatOS and to do my own custom configuration slightly. It's still good information if your board is not supported, so please go and have a look at that. What we are going to do now is, here's the warning about the memory issue. So the next thing we're going to do is we're going to put that SD card inside the Raspberry Pi, and we're going to boot it up, and then we're going to start with configuration. Now, I did prep the file up front, but it's still stuck in the back here, so let me just grab it out. All right, so here's my micro SD card, and we're going to now take the Raspberry Pi. I'm just going to clip it off, and the reason why is the housing I made is brilliant, but it is a little bit, can I say, very touchy to get that SD card inside that little groove at the bottom, so just easier for me to take it out and do it. But once I've got it in, we can plug it back into the machine. Right. Practice makes perfect. Done it a couple of times. So what we can do now is let's go to this one over here. I'm going to plug my USB power in there again because it sits pretty close. I've got my USB cable. Let me just zoom out just a fraction here, and you can see. Turn this up slightly. Okay. So you can see I've got a USB cable that's going to the main controller into here, and I've also got one more wire that goes to the breakout toolboard that I'm going to have on my head. So I'm going to plug this in now because it's a little bit tight, because I was tight for space, and then I'm going to put that in, which now sits nicely, and I'm going to clip that in. Right, so now I've got my Pi connected with power ready to go, and my freshly flashed SD card is in, and I can now move over to switching on. So switch the power on that board. You probably won't yet that far. Let's just put this one over here and do that maybe. So there you can see the power's on for the power supply, and down the bottom here you can see the Raspberry Pi is busy booting up. So we're going to give that a couple of seconds to boot up, and once it's started we're going to then connect to its Wi-Fi. I must say, I'm very excited about the new board. This board is supported, because if you look at how easy it is to do this, once it's up and running, it's really good. And let's hope nothing strange goes to happen, and that this just goes as smooth as what it would normally do, you know, and that I don't have any tournaments that I have to face while doing the stream. Hey, my dad's joined. Hi. Hope you're feeling better. Okay, so I think it should be about ready. So let's go to this view, right? And we're now going to connect to the Wi-Fi. Now, I just thought about this Wi-Fi issue. On this screen that I'm sharing with you, you cannot see me connecting to the Wi-Fi. So I'm just going to switch over to another screen quickly. I'm going to switch over to this monitor, and let's see if we can do. Oh my goodness, it's really. This is sorry about that. Let me just switch back for a second while I can't do it there. So let me just do that. No, I can't even do it that way. You'll have to watch me. I'm just apologetic. I have to quickly fix this. Right. Because I've never planned to use that screen, but it's okay. You just pull that from like that. That's good enough. So we can quickly show the Wi-Fi down the bottom here. So I'm going to click on the Wi-Fi, and I'm going to switch Wi-Fi on, and I'm going to go into the Wi-Fi, and I'm going to look, and there's my RatOS, right? I'm going to connect to the RatOS. That's on the board now, because the RatOS boots up and it creates its own SSID Wi-Fi network. I'm going to switch off connect automatically, because I don't want it to connect after this, and I'm going to say connect. And the password is raspberry. Okay, so let's just go once that's connected, we will switch back to the other screen. I've noticed it can take a little bit of time. There you go. So we connected. Yes, it will say no internet because obviously there's no internet coming through the Raspberry Pi, but that's fine for now. All right. Let's now go and switch back to, I'm not sure which one now. That one? Yes. Okay, just stretch that back. Right. Sorry about that. Anyway, I could show you the Wi-Fi. We should have maybe brought the Wi-Fi screen across earlier, but I didn't. All right, so there's the password, right? There's the password that they talked about. Okay, sorry, that one over there. And we've now connected to the RatOS with that password, and we connected. And the first thing we're going to do is click on this one. That, in theory, should open up the RatOS startup screen. First thing it's going to ask us is to connect to a network. So I'm going to connect to this one, being the strongest one close to my printer. And I'm going to put in my password. Save the credentials, and then it's asking me to give this printer a name. I'm going to call this RatRig 500 because I might have another printer, a smaller one. So I'll just give this one 500 for now. Save that. And at this point, what's going to happen now is it's now going to restart the Pi. So if we look at this picture, let's look at this one. You'll see this little light is going to go absolutely crazy again, and it's going to start flickering and getting ready. And it's actually now going to reboot and start up and connect my home Wi-Fi network, so that I'm on my network. And then once it's finished, we are then going to be able to come back, and we're going to be able to take this over here and go to that site. Now, the documentation says a little bit different. I'll just close that screen. Keep going to it. It says once you've finished setting up once you're finished, you must then go to RatOS configure step 1. Now, yes, we're going to go to that because I want to show you, as per the documentation, what the difference is. But we need to close all of these out. We don't need them anymore. I want to show you what happens if you just go over there. Or no, let's not do that. I'll show you that in a couple of minutes. So what I'm going to do is I'm going to go to the documentation. So see, it should be there by now. Right, I'm going to go to the documentation. I'm going to click on this step, and it's not going to work. And the reason why is because I changed the printer name. Right. So in order for me to actually get that to work properly, I'm going to rather copy the link address. Paste it in there. Well, I could have modified it, it eventually came back, and I'm just going to say RatRig 5. Okay. And I'm going to go enter. And we're still waiting for it to come up. Hopefully it won't take too much longer. There you go, on view, eh? Well, like the demo. The demo will work today, hopefully. So the next thing we do is they say now we need to check the main control board, and we look for it and we go Octopus. I'm looking for Octopus Max EZ. It's not there. Okay, you can see it's not in that place, and I agree it's not in that place. The reason being is when they released this file, this release of this file a couple of months ago, they didn't have the EZ inside there, but recently they've added it. So if you were to update like a firmware update or a software update, pull the latest updates from RatOS, you would then get to see that board. But because this file that we wrote to this SD card isn't the latest version, we're not seeing it. So there is a way around this, and that's what I want to show you. So if you don't see the board, and you know the board's supported, but you don't see the board, take this step 1 configure away here. Right? Just go straight to the actual main cell interface, right? And forget about everything that's over here. We'll get through this at a later stage. We're not going to do anything. Go to the machine, and on the right-hand side here, you'll see as Update Manager. Okay. I haven't seen any other place to do this. There might be another way of doing this, but this is just the easiest way for me. I go here and I go look. There's RatOS. You can see there's been probably about 15 iterations since it was released. So I'm just going to push update on that one. What that's now going to do is it's going to go to RatOS's GitHub site, and it's going to pull down all the latest configurations, and when it's finished pulling down all those configurations, we will see that it pulled down things for the Manta board. There's the BTT Octopus Max EZ, right? It has pulled those rules down. So now when I close, all I need to do is push back once, twice, and I'm back here at this configuration, right? And have a look there. BTT Octopus Max EZ. It's now added that board to this full list, and there's been a couple of boards that have been added. So now you'll see all the latest boards, and we can now click on that one and go next. And then we can say we're going to flash it via DFU, right? Because this supports DFU, we can do that. Now I'm going to click on this, and immediately they'll bring up my board, well, BTT's board, and it will say waiting for DFU. First thing they're going to say, if it wasn't connected to the USB by the RatRig Pi, they would say they would connect it, make sure the board is powered on, right? So I'm now going to power my board on. So on this side now, let's see if we go to this camera. I've just switched it on, and it's starting to boot up and get power. At the same time, this one you can see there's a little blue light. It's coming in there, saying that that was also now starting to start up. Right. Let's put that back up there. I don't want it to touch anything for now. And so my board's busy starting up. Okay. Now we come back to the main documentation, and it says that we need to, I can probably zoom this in a little bit for you to see a little bit better there. Press and hold the boot 0 button on the board, which they indicate there's boot 0, and then press and release the reset button, right? And then release the boot 0 button. Right. And I'm going to keep that there, and maybe if I do this, let's see, which camera are we? We're on one of those cameras over there. Maybe what I can do is I'm not going to worry about it now. Let's just switch over to, I'm going to leave it like that. I want you to see what happens when I push that button. But I'm going to push it and hold that button, and I'm going to click on that little button, and we will then see what happens to this over here. So let me do that quickly. Try and use something that's not conductive, just in case you miss. Right, so I'm using little wooden skewers. Right, so I'm going to push and hold boot, and I'm going to click reset, and I'm going to release. Let's see, did it work? DFU not detected. Let's try that again. Let's hold. Very interesting. It's not working. Why is that? It worked the other day. And that's where it becomes interesting. Let's go back. Flash, manually write. Okay, for some other reason this board is not switched into DFU mode. So let's just switch. I'm just going to switch the board off again. Pull that one out. Let's pull this one out. Let's see. Switch this board on again. Okay, this did work very well the other day. But let's see. Let's see if we can get this thing to work. You know. Boot 0. Wow. That's very interesting. Okay, so I don't know if it's because I've already flashed this board that it's not picking it up. Let's try something just for interest's sake. Let's just go next. Can we go next? No, we can't. Go to the toolboard settings. I want to see if check the status. Not doing anything. Very interesting. Okay. See, guys, give me a moment. Let's see if we can figure this out. I want to have a look. You see, it's definitely picking up the board because there's the board. So this might just be because I previously flashed this board, although I'm not sure if that's the right one. That's the Linux architecture. If I pull this out, I'm going to do a shutdown quickly just to see. I'm going to shut down the Raspberry Pi. And then I'm going to boot it again. See if that makes any difference. That's how we learn it. So I'm not sure why it's doing that. The other day it flashed no problem whatsoever. Picked it up perfectly the first time. Let's have a look and see if we can get this thing to do its thing. Maybe I'll run some of the Linux updates as well. And then go back to the setup one more time. Let's update all of these things quickly, all of these packages, and you can see it's now just doing a full update. I'm going to run a full update just to hopefully eliminate any possibilities, although that wouldn't make sense why I couldn't see it in BFU mode. Just don't think it needs to be fully updated. Let's do it. There's no harm in updating. Hello Mr. Fig, welcome. Hopefully you successfully helped your client. Now you run another call. We're having a challenge. The board won't go into DFU mode, which is strange. The other thing that I probably can do is actually check to see software install Movex 2. Let's have a look at that. This software install. To the start. Okay. While that's still running, I'm just going to on the side here open up a little bit of software. Busy with this update. You can see there's quite a few updates that happened since this board was released, or this SD card image was released. So it's quite busy. For updates. And I think after the updates we'll just do a quick restart as well. Busy. Getting there. Just for interest, the background music's still okay, not too loud. You should just hear it in the background. Just type in the comments. I think it's probably closed. Let's just bring this down to the bottom. Full update complete. Close that. Right, so this has now been fully updated. And let's do the following. Let's do a restart. Let's do a full reboot of the host. Give that time to restart, and then we'll go back to the configuration. Seems to be back up and running. So now I'm going to go back to this. I'm going to do refresh. I'm going to take the Max EZ and I'm going to say, okay, next. I just want to have a look on the side here. I'm just connecting with a SSH terminal on the side here, but I don't seem to be able to get it right because I think the main password is wrong, and I'm not sure if I'm using the right user to get in. Doesn't seem to want to connect. Let's carry on the side. I've got a funny feeling it's not going to work tonight. And if that's the case, we'll just stop the stream and I'll go figure it out and come back. I'm not going to bore you with it. So let's push that. Not working. I'm going to move this to a different USB port and just see what it does, just for interest sake. Voltage is on. Yeah, doesn't seem to be wanting to. See if that's in the stream. Reset it and then okay. Doesn't seem to be working, guys, and I'm not quite sure why. I'm trying to have a look also in the documentation. So I'm not sure if I'm connecting to this host with the wrong username on what's the name, on a SSH. Don't seem to be getting in, and let's just have a quick look. If we say OS SSH. Don't seem to. Password is. Okay, I think I know what I've done wrong. Let's quickly have a look. Okay, fine. Edit this. Edit session and change that maybe to one. Logged in because there's a couple of items here I can't show on the screen. Oh my goodness, and I can't type my own password. In there, and then I want to. So I'm going to bring this onto a screen now to show you. I'm logging into a SSH session where I'm actually connected to the machine now, to the terminal, and I want to just make sure if I go and look at my documentation, I've got this file where I actually keep all my SSH commands because I want to see these. There's a command that I want to run, so just give me a moment. Let me just grab that command from another machine. don't seem to be able to find that file that I used previously. General, hold on, first load, general, that's our measurement. Alright, I know where I'll put it. Let's have a look. This is where it would be nice if you have a host of people on your stream that could quickly just, you know, guide you, but sometimes you don't have that luxury. So you try and figure it out yourself. I want to see. Alright, so paste it here. And we're going to do that. Alright, so if I unplug this board and I run that again, okay, so obviously we're not seeing the main board for some other reason. It's not even picking it up on the Raspberry Pi now. Don't know if it's the USB connection or if it's not the USB connection. So what we're going to do is we're going to pull this cable out. And we're going to plug this cable in there. And I think if this is going to work, then I'm going to be very angry with myself. Oh my goodness, there you go. So as you can see, the board's working. So I'm going to explain to you in a second what I've done wrong. I just need to grab one more cable somewhere. Let me see, not that cable, this cable. Okay. So let's come back to this, right? I grabbed a short cable and I thought it was going to be working fine, right? But when I tested, I didn't test with this cable. Not all USB-C cables are data cables. Some of them are only charging cables, right? So it only pushes power with no data. And that's why this cable will not actually connect to that board. And that's why over here, you could now see that board's in DFU mode. So sorry about that. Made a mistake there, but that's fine. I will quickly correct that. So we're going to plug this cable into this one. I'm going to plug it back in here, and you're going to have to rewind your head a little bit and just go back as if you were like 10 minutes ago. I'm going to put that over there. I'm going to go back here, and can you see what's happened? As soon as I pushed that, it went into flash mode. So let's just, for the sake of doing it properly, let's just go back quickly. Let's go. Oops, sorry. We go here, right? I'm going to just reset this board. Then it comes out of DFU mode. I'm now going to click on Max. So the full update wouldn't have been needed, but again, it's not really, it really doesn't harm. This is how we learn. You'll see because the cable's now working, it's actually picking up the Octopus, and it's detected and said this board is running version right? You can flash it again if you want, right? So I'm going to click on flash again, and I'm going to say flash automatically, and it's going to go like that. In the other case where if the board wasn't flashed at the right version, I would push the boot, push the reset, and it'll actually go into DFU mode, and then the board would actually do the flash. So apologies for that. That was a bit of a mess from my side. But now I've learned a lesson again. Never just trust any cable. Good, we can continue, because now I can show you the rest of the setup, which I'm very grateful for. It's busy flashing that board. And the flash doesn't take that long, in theory. That does help to, in my case, I do have a little bit of skills working with the SSH terminal, and that's by going to the SSH terminal, I could see that the actual board wasn't connected. Alright, so you can see it's flashed, it's done, it's happy. Right, we go to the next, and then it asks you for which tool board are you going to connect to. Now, if you don't have a tool board, you're just going to skip. But I do have a tool board, right? And I have got the, I will check the version. I've got the EBB 42 CAN version 1.2. EBB 42 version 1.2. I've got that specific one, right? And I'm going to say next. It's now checking the version of this board. Again, it says version mismatch. The board is running a version, but you can. So let's flash it again. And this time I'm going to flash it manually via DFU so that I can just show you what it looks like. Because if I do flash automatically, it's just going to go past. Let's just do the flash manually. There it says, right, waiting for DFU mode, and in this one it will show you there's the boot button and there's the read button. Same process, we're going to hold the boot and just press and release reset, and by that we should see that come up. So let's do that. Put that one in. I'm not holding it properly. Click reset. There you go. Once I finish clicking that, it's now activated, and I can push flash, and it does exactly the same process as the big board would have done. Okay. Again, their documentation is very good as to what's happening. Just don't get caught out with stupid charging cables. And that's one thing I really can't understand, why they don't mark them in some other way to say this is a power only cable and not a data cable. But having a look at the pins, yeah, there's some pins missing there. Right, finished. So now we've flashed both boards, and we can go next. And it says now that your controller board is configured, you can now connect your printer to the main via main cell and start configuring your calibrating. Right. So we're going to open up main cell. There we go. Yeah, we're back in main cell. Now, my recommendation is before you do any step here again, if you haven't done it, although we did it earlier, do the update. So if I just run the update manager again, it should find 0 updates. Okay, and if there was updates, I could run them quickly. One nice thing about the way the updates work now with the RatOS, and because I'm using boards that are DFU compatible, right? If there are updates and I click updates, right, it will automatically push the updates to the boards as well. Whereas if you don't have boards that are supported, and you would have to go outside the software, create the flash file, upload it, put it onto an SD card, put it into the controller, start it up, flash the board, then come back out. It's a bit of a long process, but using supported boards really makes a big difference. Let's upgrade again. So I'm gonna run the upgrade again quickly. Sorry guys, I want to make sure before we proceed, I want to make sure we're 100% up to date. And again, most updates don't take too long to deploy. Specifically if you're running a Raspberry Pi 4, and they're pretty fast. If you're thinking of buying the Raspberry Pi 5, you can. I don't see why it shouldn't work and why we should have issues, but there might be, it's overkill, because a Raspberry Pi 3 is good enough, so even the 4s are overkill, but you can do a Raspberry Pi 5 if you want. I'm just not 100% sure if RatOS is fully supporting it yet, but there will be somewhere on the documentation you can have a look and see if you can get some comments. I can't see why not. And if it's not fully supported by RatOS yet, it will be eventually. Closing off my other stuff on the other screen so that I can see what's happening. Where are we in terms of time? We've done well, and it's 9:15. Not that far behind. Difficult to say, not most updates don't take too long. It takes a little bit longer than what I would normally expect, but it is a package update, so I guess there's quite a few things that are installing. I just got myself for my for the Boron V0. I'm using a Wise 3040 controller board inside there, manually set up, and there was a shop selling Raspberry Pis on the Raspberry Pi 4 with 4 gig RAM on specials. It's like 25% less because they're expecting the 5s to come in. So I thought to myself, why not? Let's upgrade that one at least to a Raspberry Pi 4. I'll be doing that on a stream as to how I upgrade that as well at some stage. Okay, done. We're up to date. What we're now going to do is go back to the main dashboard, and this is part of the setup that we need to continue. So if we go back to the instructions, they tell you once you've done the configuration, right, then you go to main cell OS, and when you decide that, you then follow the instructions of the setup wizard that's over there, right? And again, they will also talk about doing updating, right, and updating all the commands, and then they say you can always go back to the configuration if you need to do any configuration changes at a later stage. The configuration pages aren't a once-off usage. You can use them multiple times if you want. Okay, so I'm installing a printer, a V-Core3, right? So because I'm going to do the V-Core3, there you go, I'm going to click on that button. Interestingly enough, they do support some of the Borons and some of the Pruses, and I'm actually going to try this on the Boron V0 with the RatOS and their configuration, because I just like the way it works. And I'm going to be putting inside that board, into that printer, also a Octopus, but not the Max EZ. It's just the one of the EZ boards that I have already lined up. So let's click on this. What it's now going to do is it's going to write a whole bunch of files and set up a whole bunch of configurations for me. And once it's finished with that, I should be able to now go into the setup, right? So it says over here V-Core3 config install. Please open printer CFG file. Let's go to the printer CFG file. If you do see an area, I'll just click on that just to show you if it does throw up an error. don't worry about that, because we have to do a couple of settings inside the printer CFG file. So this becomes fun. Now you need to read a lot of reading. And again, if you look at my part 7 video and part 8 video, this will be totally different in terms of what we were doing previously. We're now going to go through this file and start marking off. You can see here the first thing that says what controller board have you got inside, and it's by default everything is always Octopus 11 board. We're going to comment that out, and we're going to open up the Octopus Max EZ, right? And we will look further, and as we're going down the file, it says this is to increase motor torque. Accuracy and limits, don't enable this before your printer is fully configured. Okay, we're not going to do any of that right now. Stealth mode, enable stealth mode, buffer. Again, we're not going to do anything over here. I know I've got the 2209s, right? But again, I'm not going to go for quieter. I'm going to go for more accurate. So I'm going to leave that off for now. We'll see how it goes. If it drives me crazy, I'll come back and switch it on. Then it's talking about the physical dimensions. We need to pick the printer size. I've got the 500 board frame in place, so I'm going to select 500. Homing, what are we going to be using? We are going to be using, I was originally going to use the capacitive probe, right? I'm not going to be using that anymore. I'm going to be using a beacon because that's now supported. The only thing is the beacon isn't installed yet, which we will do at a later stage. But I will open that up now and see if it gives me any errors. I'll just come and switch it off for a little while longer. Actually, until I've installed the beacon, I'm not going to enable it. Right? I'm just going to keep it out there for our physical end stops on. Right? I'm not using physical end stops, right? I'm going to use sensorless homing, so I'm going to switch that off. And over here it talks about sensorless homing. It's strongly encouraged to use physical, so if you're a beginner, I've been using sensorless homing on my V-Core printers, on my Voron printer. I really enjoy it, so I'm going to be doing sensorless homing. I'm going to enable those two. Alright. Input shaper. I'm going to do an input shaper, but I don't have an ADXL connected directly to the controller board. What I have is inside my EBB42 board. There is an ADXL, so we'll leave that for now, but this is only if you're connecting it directly to the Octopus board. My tool head will be, let's go here, it will not be right, it will be this one over here. 36S TH20 motor. I just want to have a quick peek from 36S TH21 004. Yep, that's that orbiter that I've got. I've got the newer orbiter. The hot end that I'm going to be using, unfortunately, it's not a repeater, but I'm actually thinking of upgrading that at some stage. But I am going to use the Revos for now. Fans, I have got to decide. So my the controller board will be a 4-pin fan, right? And so I just got to figure out whether I'm going to do a 25 kilohertz or 50. I'd actually I'll be very honest with you, I'm not quite sure what the difference would be there. I'm not sure what frequency we're going to use it. So now, because I haven't got the fan connected to the main board at this point in time, I'm going to leave it off. I'll go and research that a little bit and just understand the difference between these two, but I have to enable one of these two. Again, part cooling and hot end cooling, I'm going to be doing that via the EBB board, so I'm going to skip that for now. I think the configuration is a little different later on. Yeah, we don't have to do anything for now. Printer configuration, this is your stepper, pins. This has all been done for you. You're not going to change any of this. I'm not doing BL touch. I'm not doing an inductive. The probe offset would be important, and this would be such a super pin super. I would have to read up a little bit about this in terms of the beacon as to which one that might be, but I think for inductive probes we don't need this. I might need to come back here just now when I go to the beacon, although that would always be required. Z offset. Extruder, we are going to use a 0.4 nozzle initially. Direction pin, okay, so nothing we need to change over there. This is for the ADSL resonance testing. Right, here's the toolboard, right? So we're using the EBB42. Okay. Included. Right. If you have a toolboard installed, uncomment the following. Not using that. We are going to be using the probe again. I don't know if we need to remove one of these. Obviously, I need upstairs at the top. I need to change one of these. I'm just not sure which one of these is the beacon. It's the same thing over here, so I might need to come back to that. So for now, I'm just going to leave it like that, but ideally that would switch off and maybe one of these would come on. Right. If you need the directional extruder to be changed, we can change the delay. If you have your X in stock connected to your toolboard, no, we don't. To use the toolboard's ADXL, yes, we're going to use the ADXL's tool, right? And that's it. So now we've pretty much been through this file, and we can save and restart, and let's see what happens. Okay, hold on a second. I don't think I read everything over there. So we'll just go back into this file, and where the sensor is homing, yeah, it says beware this thinking. Copy the config templates senseless homing to the root directory and remove the hash from the line below. Then tune the settings in it until you have a reliable homing. If you only want to run senseless homing on a single axis, right? Okay, so I made a mistake here because I'm going to be running on both axes. I'm going to comment that out again, and I'm going to uncomment that. Now we're going to go copy under the templates the senseless homing to the main root. So let's just save and close. We go under RatOS templates, senseless homing X, Y. This is the one that does both. There's no way to actually move this file across or copy paste it across as far as I know. You can't. There's no fancy way. So the only way I know to do this, guys, apologies if there's a better way of doing this. I download the file, which means it's now downloaded to my local machine, and then I go back up, up, up. Yeah, where my senseless, my root config is again, and then I want to upload a file, and I take from my downloads, or at least I think from my downloads. Where did that from go? Where did that from go? Keep. Folder. Make sure it's in the right place. Downloads, there it is, and I can open that, copy that inside there, go inside here, to override this file, right. So what's going to happen is at some point, as part of the senseless homing, I'm going to change the store guard settings, this number and this number. For now, I'm going to leave it as is because I'm not going to be able to test it. It's just what it is, and nothing's going to be moving in any case for now because I haven't connected the motors. So if I save and restart, whatever are we getting now? File contains no section headers. File contains no section headers. File home line 7. Line 7. Okay. I think somewhere over here. We're going to put that out for now. Let's see if that is my problem. Okay, it's the option in probe section, so let's just go back to the probe section. For now, I'm going to put that until I've figured out how to add the beacon. Oh my goodness. Probe points in section resonance tester must be. We've got quite a few errors coming through here now. I'm not going to be using the inductor probe, so I don't know. My feelings, this shouldn't be there. But if I do that, I think I'm going to have more errors. So option probe points in section resonance tester. Okay, I'm not sure where I'm going wrong on this one. Let's say for argument's sake, I was going to put in the finger probe, which would have been this inductor probe here. Let's just see if I do that, if we actually get past it, then I can come back and do the beacon later. For some other reason I can't find it. Is that maybe in this file that's maybe? It's this file. I only included that, which is fine. Saying that I'll probably use a capacitive probe. Let's for now remove the sensorless homing, and let's say for argument's sake I was going to put in stocks. I just want to see if that makes a difference. Let's just go up until this point and see what it gives you. At least when you can get closer to the error somehow. Doesn't seem to be getting closer to the error. So none of that what I'm doing is actually influencing that. I don't know what it is. So, because I'm specifying the input shape over here, I have to specify over here probe points. Like that. Silly. Okay. So I'll still leave this probe as if I was going to do the Pinder probe. Okay, and I'm going to come back to this section. I really am not going to do that. I'm not going to do that, and I'm going to do that because I want to do the sensor summing and the inductive. Oh, let's just switch it off for now. Let's see. Am I getting anywhere closer to having? Well, look, I'm still expecting an error because nothing's connected to the board, but I'm expecting a very specific. You see, quite a bit different now. Okay. So this is what I wanted now at this point, because pretty much the board, the configuration files are fine. Yeah, we can see that it picked up. This is the main board, right? The Octopus board, and this is the tool board, right? The little tool board that I have that's running. So it picked up those items, and that's all I really wanted now, and it got to this point. The reason why it's throwing this error is because a temperature is out of range, meaning on one of the temperature sensors, I don't have anything connected. And so it's trying to read a temperature sensor and it's actually going to crash. Right? That's fine for now. When we get to this point, I'm pretty much happy that we're in a position where at least I can now start all my wiring, get all my motors connected, get everything up and running, and then once I got that, when I run this again, in theory, I should then be able to move past this error. If I had to plug in a temperature sensor on this probe now, which I don't have one lying around, and it's the MCU toolboard. Yeah. I don't have a probe. If I've connected a probe onto the temperature sensor on the probe toolboard and on the main board, I'd probably get away with getting this board up and running. But I think that's it for the firmware. Sorry, it's a bit of a jumping around, but not reading. But you see, you actually got to go through that whole setup very slowly. My big problem again here was I'm not 100% sure how to do the beacon, so I'm going to have to figure that out. Although it says just connect it. Everything is already installed, just connect and run. Okay, so if I do that, what happens to this section? Can I then uncomment that? Which I think doesn't make sense because I still need a Z offset somewhere along the line. But I'll figure that out when we get to the time. It's probably going to throw the same error out, or try and find the pin the probe or something like that. So I'm going to get a different error now. But for now, I think I'm at the right place. So I'm going to stop with the firmware. Okay. We still got. The plan was to stream for about 2 hours. Good thing is we've actually got to that point where I'm capable of actually doing it within the time frame. So what I'm going to do, I'm going to comment this out again. Put this back, and then I'll go and read up a little bit more on that one later. What I'd like to quickly do is I've done some modifications to the bed and to the bed setup and the front. So I'm going to quickly show you that and how I'm connecting up my bed. Yeah, maybe someone will have some ideas or have some comments. I think, yeah, spelling and grammar check. Yeah, it's more I need to just read properly. Hopefully spelling and grammar is not needed. But also the knowledge of how to set up this thing is expanding. So I don't know everything, and as we're going, I'm learning as well. So let's come back to the main screen, and what I'm going to do it's just, I'm going to do a shutdown now because I don't want anything to go wrong, and I don't want to pull the power on the board until I know that it's shut down properly. Right, it's shut down. Okay, so I can now switch off both power supplies, and I can pull out the AC cable, and I can now, let me move this, excuse this camera, I'm going to move it a little bit this way, because I want to show you what I'm doing. And in order to show you what we're doing, pull that out and pull that out, and I need to move this camera out of the way. I don't think so. Yes, I have my whole printer on a swivel, on a like what they call a lazy Susie, and so I can swivel the printer a little bit, and I put these little rubber blocks that I put on, otherwise the printer goes all over the show. And I'm going to bring this camera inside here because I want to show you that. How am I going to switch over that? That's the side camera. Okay, there you go. You can see pretty much what I want to see. So what the heck's going on there, Raymond? What are you doing? I've got this crazy idea that I'm going to, instead of running a 500mm bed permanently, which draws 1500 watts for whatever print, I also purchased a 300mm bed. And so I want the ability to pick up my bed, remove it, and put the small one in. And to do that, the big thing is I need to get the heater, the bed heater to switch over, the bed thermistor to switch over, and the earth cable that I'm going to be running to the bed. Okay. So in order to do that, I've taken my cables, which would normally go straight from your bed heater, from your bed to the back of the printer. I've taken it and I've put a connector in between. Now I need to test this connector, and we'll see how it does. Apparently that connector can handle up to 8 amps, which is more than sufficient for what I need. And also I didn't want the cables just hanging down the back, so I put in a chain, right? And if I was to take this chain, you can see I can lift this. I've just taken the rod out for now, just so that I can work with it, but this moves up and down pretty freely. And if I go to the top, it will go all the way to the top, right? No problem. So that is pretty much what I am putting in place. I've now put those connectors there, and my wife has come to steal my phone, right? And I'm going to show you the connector that I'm using. Now, I can't totally put this bed in at this point in time, but essentially that's the connector, right? You should be able to see it in the view there. It's going to plug into there, and then it'll screw on tight, and I will be able to remove this bed, put it in and put it out at any time. Okay. I have the same idea for the 300 bed. My challenge being with wanting to do that, these arms, right, where the bed would be standing on, obviously are going to be too short. So my challenge that I have is I have to come up with a way to either extend the arms so that when the magnet is probably going to be, if I do this, maybe I'll just do it like this. let's say the magnet's going to come, normally plugs in there, maybe the magnet's going to come out there. So I would need to extend this up to there. So I need to figure a way to either extend these, or on my bed I must figure a way to extend the magnet to come up to that, right? So that's one of the challenges I've got. Now, am I going to get it right? I don't know yet. Is it going to affect my printing? I'm not sure yet, but I'm going to give it a try. This little connector over here, while it is very tight and very difficult to get that in there, let's see if we can get this focused. Right. It will have a little cover on so that nobody can see my wiring in the background, and I will just be able to push the plug in, pull the plug out, and it actually screws on. Safety. So that's that portion of it, right? So let's go back to that camera, and we pull this out, and let me do this. Zoom out on this camera here, and show you. Let's see where am I doing this camera? If I go to this camera, you can see how nicely it is. If you're working on a printer that's that big and you don't want to walk around the whole time, you can put one of these lazy Susie heavy duty wheels underneath and get it to move around. So let's zoom in on this now and just quickly have a look at what have I done here. Do that slightly, and hopefully I don't ruin it. Yeah. Okay, so here comes in all my wires. First of all, I've got the earth wire that's coming in from the bed. It's going down the bottom here and connecting up over here. So it's connected to the earth. I still need to connect the earth wire to the frame, although I found that the frame's not earthed yet. I need to find a good place to frame. So I did tests on the frame all over the show, just to see if the frame actually connects everywhere. And yes, it's connected everywhere. So it doesn't matter where I take my meter and plug it in. I can test it. I've got continuity. So when I can just take any point on the actual printer and frame it, but I'm going to take a bit of the paint off and actually make sure I get a very good earthing on it. The next thing is I've got the two bed heater wires coming in. One is going, it's just a little bit in the way, I'm going to lift that up. One's going in and going to my neutral, right, because it's an AC bed, so it needs to go to the neutral. This neutral's coming up, it's got a bridge going up like that just to get to this set of Wago connectors. The reason why I had to go this way and not down the bottom is this wire is just not long enough to get to it from the bottom, which is a bit unfortunate, but that's just the way it is. Then the other wire is coming in and it's going to the SSR, right, because the SSR is what's going to switch it on and off, and on the other side of the SSR that goes through to my line, right, which then closes the circuit to give that heater AC power. And with your DC side of your SSR, going to connect that to your bed out connector, right, and that will control your bed heater. Then I've got the little red wire that's come in here, right, and let's grab this see if I can grab this connector out of the way here. Okay. And that one's going to go in there. Okay, so again, the thermistor's coming in, going around, and we'll just connect straight into the bed over here, right? Nothing fancy, that's the way that works. Made little printouts to holes and drilled holes and everything so that I can get that chain running up and down. Took quite a bit of design, quite a bit of moving backwards and forwards and changing sizes, but that's also working well. So in fact, my bed connectivity is pretty much done, barring the fact that I need to go from bed out to SSR. I'm already done with that. I think the last thing that I'll quickly show while we still have a little bit of time, and let me just switch back here for a second, and then I can take my little camera that is now sadly lying on its side. I'm going to lock this in place. Okay. Let's bring this aside for now. Okay. And I'm going to use so you can't see me, but that's not the most important thing. So inside the bottom of the motors, we need to connect our motors all the way through to the back of the printer. We go through. Now I'm not going to drill holes anymore. I'm going to keep my wires at the bottom. I want to keep them underneath. I don't want them to come into the bed because I'm going to actively heat this chamber, so I don't want the wires inside. And in order to keep the wires neat, I printed these little things that I got on printable somewhere. I'll find out where I got it from originally, and then I will give the guy credit, whoever designed these. So essentially, let me just see if I do this, you can see it a bit better. Yeah. So it's a 30-30 connector for the aluminium 30-30 tubes, and it's got a little hole that goes through where you can actually push a cable tie through and hold whatever wire you want. So with that, I placed them strategically along my printer, right on the sides, and if I just move this a little bit this way, swing around to the other side, you will see, well, that's what it looks like. So this wire is running inside there, and I've just put this protection over it, and I'll be able to run all the way around that side of the printer. It's all the way down there, and then it comes to pretty much this piece over here. Now what I'm planning on doing is bringing both around, and then I'm going to go and take it underneath the printer like this, and it's going to go to the back, and I'm going to use these little connectors at the bottom to hold, and so I can cable tie, because they don't sit that far away, so there will still be space underneath and won't be on top. And I'll bring my wires through to the back with those connectors. That I'm going to finish off in the next stream. I will do this other motor that still needs to be finished. I'll do that one, and I will do that motor connection in the next stream, and then we will be able to connect through to the main board, our motors. So that's where we are for now. We're on the 2 hours now. I think that's all I'm going to cover for tonight. I'm very grateful that tonight's stream actually went well, that it didn't break up like the previous one where we had to abort. I see my dad saying change is rolling, the limit's perfect with extra millimeters added. Yeah, it just fits, and it just works well, and the cables are just long enough. So there's so many when I say it was that little housing at the bottom, I designed that, I printed that probably about 7 times, 8 times before I actually got it to the right place and the right size. But it really looks nice. And again, yes, you can have your cables just hanging around. I could have just had the connector connect, but why? I think it looks a lot nicer with it being in a chain, and hopefully someone else likes it and can use it as well in the future. So that's it. Without further ado, I'm going to move on. If you're watching this video in the future, I hope it helps you. And by me battling a little bit tonight, I hope it shows that we don't always get it right the first time, but we must persevere and get our heads around a lot of this stuff, and we've got to watch out for stupid things like power only USB cables. So I'm glad that actually happened in one way, that people will know that. And the next session, I'm not sure if it'll be this week. It's pretty full this week, probably only next week. But in the next session, in part 12, we're really going to focus on connecting all the stepper motors on the bottom and the stepper motors at the back. And then we're going to start looking at putting the toolboard onto the main print head and doing the last bit of that wiring, so that we can get to the point where we can actually switch on the printer and have movement, because pretty much all that's there is wiring that up. But that wiring itself, the toolboard wiring and the motor wiring, will be a full session. It just takes time. So I'm actually going to see how much of it I can prep up front. So yeah, please like and subscribe. Throw comments into the comments section if you've got any comments, and yeah, happy to answer wherever I can, and we'll see you on the next stream. Thanks for your support, and have a good day. Cheers.